Hi everyone. This tutorial basically a continuous from the previous tutorial about assembly language. Just quickly to basically explain operation code and operand. Each assembly language statement is split into an opcode and an operand. The opcode is the instruction that is executed by the CPU, while the operand is the data where the or memory location used to execute the instruction. So here, as you can see, if you go to the university website, um, you have coco IDE software. Just follow the instruction and you'll be able to install it directly. And then you run the batch file and you will get something like this interface. Now, this middle screen here is the compiler, here where your instruction goes. Here also your registers. As you can see here, we have 4 registers, and I'm going to show you that in a bit with some examples. And here, when you press compile, then basically checks for errors and make sure before you click start, you adjust the speed of the execution. Now, if we look here at this example, which also on the university website, you can just basically copy it down. This is a test program with some instruction here, which I'm going to explain these instructions for you in a bit. In here, as you can see, the registers, so R0, R1, R2, R3. Now, in here, we have the, where it says page 0 is the memory. Also, I just quickly want to mention hashtag. In my previous tutorial, I mentioned a semicolon for a different assembly code. We use it as a comment. In here, we use the hash, treat it as a comment. So basically what it does, it just skip that section of that bit. It does not, the program does not execute whatever it's after that hash. So for example, here we have this comment, the values together. So the program will skip from 9 into 11. And then the same here, as you can see, skips line through 13 to 15 to halt, where we basically to stop the program. Also, we have here ACECT here. It's a pseudo instruction. And also is called pseudo instruction. As you can see, it's kind of highlighted in green. That is the same. This basically 0x00 is the offset. So pseudo instruction is basically to tell the compiler to align this section of code at a given memory address. So this pseudo instruction is basically to tell the compiler to align this section of code at a given memory. Now, as you can see here, once you run, once you click compile, then it's kind of highlight around this section here, first line of code, which is line 6. Lines it for you in orange. And then once you click start, then loads the instructions, which is, as you can see here, we have this in the compiler. Here we have 0, 0. So we have here the 0, and there we have 0, 0. And then we have the 1, and then we have 0, 1. And then we have here D2, then 0, 2. And then if you see it in 06 is D3. So here we go. So we have in memory 6 here, D3. And then after that, we have 03. That comes in number 7. And then if we go to 8, we have 14. Here we go. 8, we have 14. 9, here we have 18. And then here in A, we have 1C. Here we go. So we have 0A. So as you can see here, it's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, F. So what does that tell you? This is your husky. Yeah. So no husky is base 16 because after 9 we have 10, 11, 12, 13, 14, 15. And as you can see here, the same thing, the side of your page memory. So here CPU begins the executing at basically this location. So in here, the first instruction is basically D0 for load R0. Yeah, so here the LDI is load, ADD here we add. So before I just get into details on testing it, let's just basically understand the registers section. Now, if you look at the register sections, as you can see here, when we loaded, for example, here 06, that so we loaded in register 0, 06, which is hexadecimal, and also here you can see positive 006, as here you can see is assigned integer, and then we have 006 and signed integer, and then here we have a binary, which is basically 000000110. Okay, and then let's have a look at this one here. So we have 0001 load in register 2. So this is register 2. So we have the 02. This is 02 loaded in register 2. So this is just the instruction line, which is line 1. And then you can see line 2 here, 0002, or you could just say 2. We load in register 3. This is register 3. We load this binary, which is 00000011, 00000011, which is positive 3, 3. Well, if it's assigned integer, it will be positive 3, 003, or unsigned integer, which is 003. Now, this is a setup program. As you can see, if you remember from my previous tutorial on assembly language, I mentioned about how we refer to assembly code as ASM. So here we're performing the calculation where 1 plus 2 plus 3. So here it's quite self-explanatory. As you can see here, we're loading R1, 1, here in register 2, and then register 3. We're adding this binary. Then we add the values together. So we add what's in register 1 to register 0. We add register 2 with register 0, and then we add register 3 with register 0, and then the result of will be 0 plus 1 plus 2 plus 3 in register 0. Halt, basically just to stop, and then we end the compiler. I hope you understand the process of how we basically run a basic assembly code using Coco IDE.